me set this up so I don't have to punch myself in the face again. And here's my little robot arm mock-up made out of potentiometers. So we'll put that in roughly the same position. And I soldered a neat little switch down here, so when I turn this on, hopefully... Jesus! Hello, people of Earth! Shady Dave here. I'm here in the Dave Cave. I am doing something kind of interesting. I went out last year. I was feeling rich, and I got myself this thing called the Bioloid. It's a robot building platform. Basically, it's just a bunch of loose servos that have some rather unique qualities. The servos in the Bioloid platform are actually called Dynamixels. They're this one here is the AX12 Dynamixel from, what is it, Robotic? It's this really neat Korean company that does this neat kind of proprietary robot building platform. Now these things are kind of tricky because the regular servos that I use, like this guy right here, this Tower Pro that I got off, what's it called there, Deal Extreme, is a digital servo. It's got a metal gearing system, and it's pretty solid, pretty robust. It's really good for like RC cars and remote control helicopters and all this kind of stuff. But it kind of lacks in the fact that you have to have one available port on your robot building platform, like this guy here. Here's a little propeller board. You can only fit about, well, you can fit 15 servos on this platform. But let's say you wanted to fit a lot more, or you didn't have a propeller board, you only had like an Arduino or something. This probably wouldn't be the most efficient way to go. It turns out that there's an alternative with the Dynamixel from ArbotiX. It's got a shift register, so basically you can daisy chain them together. When I was talking about the shift brights before, you remember my little shift bright project with the mirror. The shift brights, the shift in shift bright stands for shift register. So basically, you can daisy chain all these things together, and each one has a different ID. Now, the IDs are assigned dynamically on the shift brights. So you have like, you know, the closest to the board is 1, and then, you know, 2, 3, 4, 5, all the way down the line. So you can actually target individual shift brights and, you know, have them light up in different patterns and stuff just based on your code. So the Dynamixels actually operate in a very similar way, except each one comes pre-programmed. Well, in the Bioloid kit, each one comes pre-programmed with an ID. This one's like ID 8. It goes all the way up to, you know, however many robots, or I think 12. You can get 12 different guys. Anyway, so the whole idea is these guys are really robust. They give you quite a bit of torque, like 16 kilograms for like a centimeter out. It's 16 kilograms. Come on, that's crazy. So anyway, I worked with these things a little bit in the past, and I found that the CM5 module that came with Robotics, the control module, is kind of limited in what you can do. I mean, you can use their proprietary platform, which is written in .NET, but I'm a Mac guy, so I don't really have, you know, ready access to any Windows proprietary platforms. So if I wanted to write custom code for it, I'd have to learn a whole new operating system and a whole new language in order to do it. Wasn't really interested in that, but I really do love these servos. They're so friggin' strong. So what I ended up doing was, aside from going out and buying a PC and banging my head against the wall trying to learn .NET, I went out and I got myself something called the ArbotiX board, which is actually based on Arduino. Here's an Arduino here. It's an Arduino Della Nove. It's like a really old version of the Arduino Uno. I'm just going to show you here. Now, here's the ArbotiX board. It's quite a bit beefier than its little Arduino cousin, but it's using an Mega chip, which is actually really cool, because it means that you can use your Arduino bootloader or your Arduino sort of libraries and stuff with the ArbotiX board. The ArbotiX board is built by a company called Vanadium Labs. ArbotiX robocontroller from Vanadium Labs. This robot board is pretty cool in that it has individual analog inputs and it has digital inputs over here, just like your Arduino, with your analog and digital, except everything's kind of based on this whole robot building platform. So everything is servo wire compatible, which is really neat. You have a positive rail, a ground, and a signal wire for every single input on here. You have a couple of standard servo ports here. You have like a bunch of different ways to communicate with the board. An XB chip fits here. An XB chip is basically an open source wireless interface. Here's the XB radio right here. It allows you to interface wirelessly, so you have one of these on your board, like boop, and then you have one of these connected to your computer, and you can actually communicate with your robot wirelessly, which is pretty neat. So if you look here, you have your really beefy Atmega chip. This is like a, I don't know, I think it's a 32 or a 64-bit. It's really, really good. It handles a lot of code. And if you look here, here's your proprietary shift register ArbotiX thing. So if we go way over here, you'll see I had to do a little bit of hacking. I used some shape lock thermoplastic in order to put this thing on a microphone stand so it would actually stand up. But this is my robot arm. It's amazing. Look at that. Robot arm. I think it's friggin' cool. Anyway, I was having quite a bit of trouble with the robot arm because it has so many servos on it. It's like a 7 degrees of freedom arm, which is a little intense. The reason why I was having troubles with it is I was trying to power it off this little, sort of hobby adapter, and it's rated for about 600 milliamps and 12 volts. Now, I'm not an electrical engineer, guys. I'm barely a software developer, so I don't know what the heck I was doing. I plugged it in. It only worked with maybe a top of 3 servos before the board started going into this weird kind of reset loop. So what I ended up doing was I started toying around with remote control airplanes last summer, and I found my old lithium-ion battery. So I figured, well, if it's got enough juice to sort of get something into the air, it might have enough juice to power all these servos all at once. And it turns out it does, with a vengeance. The thing ended up punching me in the face as soon as I turned it on. Because, I'm going to show you again. Because I actually built a little mock-up of the robot arm out of potentiometers. You see these little sort of volume knobs here? These guys? So all of these count as the joints, and I have these guys sort of running with these servo wires into the analog ports. So it's reading the voltage from 0 to 5 on each one of these potentiometers, and it's reading it as a signal that goes from 0 to 1023 and outputs the position data over here from 0 to 1023, and it just happens that that's the exact data you need in order to run these guys. So that's that. But what ended up happening was, as soon as I turned it on, this thing wasn't standing up. It was actually, hunched over like that, and the robot didn't know what to do, so it just said, oh my God, you want this position? And it just, punched me right in the face, which sucked. Knocked my glasses off and made me swear. So, without further ado, perhaps I will give a demonstration of this robot and its many things it can do. I'm not entirely sure what I can pick up here that won't either shock the hell out of me if I drop it or set something on fire. So let me just set stuff up here. Aha! Maybe I'll have it pick up this blowtorch, because that's always safe. Okay, you guys ready for this? Here's the LiPo battery that I'm using, lithium-ion battery, or lithium polymer ion aviation battery. And let me set this up so I don't end up punching myself in the face again. And here's my little robot arm mock-up made out of potentiometers. So we'll put that in roughly the same position. And I soldered a neat little switch down here, so when I turn this on, hopefully... Jesus! I broke the hand off the robot arm. Oops. Anyway, you can see it moves. It moves quite well. And I can turn it like this. Here, let me show you the damage I did to the arm here. Okay. I had fingers sort of coming out like that, and oh! So there we go. Yet another little piece to the electronic robotic co-host build. He's probably just going to have one arm, and it'll be used to like hold up cue cards and whatnot. It's pretty cool as an animatronics experiment, you know, for like robotic puppetry. As I get a little better at the code, I might actually do some more autonomous things with it. You know, like I'll have different positions that maybe it'll go into just by you know, hitting buttons or sliding levers, or maybe I'll work with some inverse kinematics. I know that there's an awful lot that you can pack into the ArbotiX board, so I might, you know, just have fun over the next year or so experimenting with this. The code for setting up the robot so that it reads the potentiometers is actually really simple. It's just your basic servo sketch from your Arduino like public domain example library. I just scaled it up so that it involves 7 servos, and I used the Bioloid controller library instead of the Arduino.h library in order to, you know, use Dynamixels instead of servos. But that whole thing is like a really basic setup. Now this comes with different kinds of software, like one thing is called PyPose. It's like a Python-based sort of coding engine for manipulating it and making it do a whole bunch of different poses and stuff. But it's kind of difficult to work with. I haven't been able to get it to compile properly and open properly. I think you have to open it through terminal, which is a pain in the bum. So yeah, I don't know what the heck I'm doing with Python stuff. I use Blender from time to time, and that's, you know, pretty easy to open, so I figured it would be, but it's not. It's more of a terminal access thing. So I probably won't be using that. I'll just be writing my own like hard code for this thing. You know, you set up a few variables, you can store positions. You know, like I can put it in one pose, hit a button, store all of those servo positions to memory, and then I can call it back, you know, whenever I want. The PyPose library actually allows you you set up your poses in PyPose apparently, and it generates a little pose file for you so that you can run it on the ArbotiX board. But anyway, enough about that. This represented about 2 weeks worth of work and banging my head against the wall because I do not know what I'm doing, but I'm slowly learning. So yay, yet another impractical exercise in robotics.